Hello everyone, welcome to this video. In this video, we'll be continuing with miscellaneous examples from chapter 9, right? So let's proceed on to our example 3. So in this example, they are saying that if these members A, B, C, D and P, they are given to be different real numbers, right? And we are given this particular expression. So they are saying if this particular expression, it is either less than 0 or it is equal to 0, then we have to show that the members A, B, C and D, they are in GP, right? This thing we need to show that. So here, in order to show that A, B, C, D, they are in GP, what we need to show? We need to show that they have a constant ratio. So that means we'll be showing that B upon A, this is equal to C upon B, this is equal to D upon C, and so on, right? So these four members are in GP when this expression is true. So let's see, can we make out this expression through this given thing, right? Through this given inequality. So let's simplify this inequality by taking the left hand side of it. So when you take the left hand side of it, what do you have? You have this expression. Now, can you see a pattern here? You have A square, P square here, minus 2AB into P here and B square here. So these are the terms which include A, B and P. So let's separate them out. So on separating them, we have A square, B square minus 2AB, P plus B square, right? If we take another things, it contains B square, P square. This term contains minus 2BCP and this term contains C square. So all of them, they contain B, C and P. So we have this expression with us, right? In a similar manner, we can take this thing and this thing and this thing, so that it would contain C, P and D only, so giving us this expression. Now all the three expressions, they form the complete square. What can you observe from here? That it is nothing but the square of AB minus P, because when you open it up, you would end up getting the terms like this: A square, P square minus 2ABP plus B square. In a similar fashion, you would have B square, P square minus 2BPC, right, plus C square. In a similar manner, you would have C square, P square minus 2CDP plus D square, right? So these are the terms that you would have. So it is given to us in the question that this left hand side is less than equal to 0. However, from here, because it is what? It is the sum of the squares, and you know, any square that is always a positive quantity, it is either equal to 0 or it is a positive quantity, because when you square some negative number also, you would get a positive number. So therefore this sum has to be greater than equal to 0, but it is given that it is less than equal to 0. So the two things cannot happen simultaneously. Hence we only have to take the one part which is equal to 0. We have equality here also, here also. So that implies that this left hand side is equal to 0. Thus whole of this thing is equal to 0. However, because this is positive quantity, this is also positive and this is also positive. So when you add three positive quantities, it would be a positive quantity. So how can it be 0? It could only be 0 when this is also 0, this is also 0 and this is also 0. So that when you add all the three zeros, you would get back 0 again, right? So that means each individual term here should be equal to 0. Hence we would have this square also equal to 0, this square also equal to 0 and this square also equal to 0. Now if the square of something is equal to 0, then that thing should be 0 only. Hence from here you obtain P is equal to B, BP is equal to C and CP is equal to D. Or you can take this A to the right hand side, right, and B to this right hand side, C to the right hand side, so that you obtain these ratios. And because all of these ratios, they are equal to P, so that means all of them, they are equal to each other and they are further equal to P, where P is what? It was given to be some real number. Hence from here, can you see the something? That if we take this ratio A upon B, or the ratio, actually I have written it incorrect here. It should not be A upon B, B upon C and C upon D, it should be the reverse of it. Because what is P? Here also it is B upon A, it is C upon B, yes, and it is D upon C. So here also you would have B upon A, here also you would have C upon B, and here also you have D upon C. All of them, they are equal to each other. Hence these numbers A, B, C and D, they form a GP. So I hope you understood this question well. Well, that is it for this video. Thank you for watching.